We are the grade 11 senior high school students of Universal Colleges of Parañaque. I am Dessa.
I am Seth and Thomas who is taking the video of BPTS ICT. And now we are going to discuss about the model of atom.
What is atom? Atom is the smallest unit of element. It consists of a central nucleus surrounded of one or more electrons.
It is important to realize that a lot of what we know about the structure of atoms has been developed along a period of time. The idea of atom was invented by two philosophers, Democritus and Leucippus, in the 5th century before Christ. The Greek word atom means invincible because they believed that atom couldn't be broken into smaller pieces.
Aristotle did not believe in the model atom of theory, and he thought so otherwise. He thought that all materials on Earth were not made of atoms, but instead it was made by the four elements, which are earth, fire, water, and air. Seven.
John Dalton model of atom. Dalton proposed that all matter is composed of a very small things, which he calls atom.
J.J. Thomson, who discovered the electrons in 1987, proposed the Plumb pudding model of the atom in 1904. In Thomson's model, the atom is composed in electrons.
Ernest Rutherford suggested that J.J. Thomson's Plumb pudding models was incorrect. This would be known as the nucleus of the atom.
Neil Bohr depicts that the atom as smaller, positively charged nucleus surrounded by electrons that travel in circular orbits around the nucleus.
Nucleus is the central part of an atom, composed of protons and neutrons.
All right, what is an atom? So obviously an important question to answer if we're going to be taking chemistry. And so here I have 3 different depictions of an atom for you, and they range from the least accurate down to the most accurate. And so one of the reasons that chemistry is difficult for students is because everything that we study takes place at this atomic level, which obviously is extremely tiny and we'll never see. So I promise I'm going to go into these 3 different pictures and how we use them in chemistry class. But first, I want to take you on a little mini journey that helps us think about what exactly matter is. Okay, so let's picture a lake. Give it some trees so we can tell how big it is. Okay, so we all know the general properties that lakes have, big things of water, right? And so now let's think about a bathtub. All right, so another container of water, and this one's a lot smaller, right? A lake is hundreds of times bigger than a bathtub, but the stuff inside of it, water, has the same properties. If you had to make a list of everything that made water water in the lake, you know, the fact that it gets wet, what temperature it boils at, where it freezes, what it feels like, all of those properties would still be true for the bathtub. And they'd also be true for something many times smaller than the bathtub, like a cup of water. A cup of water has the same exact properties as the bathtub and the lake. The water is definitely still water, and we all know that. And this is a big thing, right? We don't think about it that much, but how many things can you think of that have the exact same qualities, the same size as the lake, as they do as a cup of water? right? A skyscraper that could be the size of a lake would not have all the same properties if it was the size of the cup, but water does, because this is all the same substance, and that goes for even something much smaller than a cup, like a drop of water. And if we took this drop and we cut it in half just exactly, we just have a smaller drop and a smaller drop and a smaller drop, and this would continue and continue and continue until we hit a certain point. And this point is 2 times 10 to the negative 5 meters. And this is an important point for us because this is the limit of a human eye. And so for us, we can't see anything past this, including our drop of water. But we could keep going if we got a microscope and something tiny, and we could slice and slice and slice this water, and it would continue to have the exact same properties as all the drops before it and the cup of water and back to the lake. It would still be just as much water as all those things until we hit this point. And this is 2.9 times 10 to the negative 10 meters. And this is the diameter of a water molecule. And if you sliced one more time at this point at 2.9 times 10 to the negative 10 meter, now at this time, this would be the first cut that you made that would no longer be water. It wouldn't have the properties of the lake and everything else that came after it. Because if you sliced this in half, you'd be slicing in half a water molecule. And so in our next stage, we wouldn't have water anymore. We'd have oxygen and hydrogen. So it would act completely differently. You couldn't drink a cup of this if you cut them in half like this. It wouldn't feel wet. It would feel completely different. And so this is the point where we study chemistry, because in chemistry, we're really interested in asking questions like what happens when we're dealing with things on such a small level, and what are the properties of these tiny little bricks that make up everything that we see and interact with. And these tiny little bricks, of course, are called atoms. And our technical definition of atoms is the smallest unit of matter that has the properties of a chemical element. So just like I've been talking about, it's the smallest little portion that still has all the same properties of something larger and larger. So in chemistry, we want to study what's happening with these atoms, and we want to learn things about them. And so now let's get back to our 3 pictures and talk a little bit about each one of them. All right, so let's start with our picture on the left here, and this is the most basic picture out of the 3, and just because it's the most basic doesn't mean there's anything wrong with it. It still teaches us certain things about atoms, and so let's take a look at the 2 things that are in this picture. So first we have this big circle in the middle, and that's the nucleus. And then surrounding it, we have these little loops, and those are the orbitals. And even though it's not an official part of the atom, I still want to point out something else, that we always have space in between the nucleus and the orbitals. So don't think of an atom like a rubber band ball and that the orbitals are one more rubber band added to the ball. The orbitals always take up a lot more space than the nucleus, and there's always some space in between the nucleus and the orbitals, and in between the orbitals themselves. All right, so this picture shows us just what are the most basic components of an atom. And for all 3 pictures, I think a helpful analogy, because remember, we're never going to see an atom. These are all things that are so small that they're really far away from the things that we think about. And so I like to think of if we had an assignment that was to teach an alien what a bird was. And so this is weird, but stay with me. Okay, so let's just imagine that we have to teach an alien who's never going to see a bird what a bird is to the best of our abilities. And so if that's true, then this first picture is a drawing like this. So some people do draw birds like this, right? And it would teach the alien a couple of things. It would say, okay, a bird is this thing with the middle and then 2 things coming off of it. But it's very simplistic. There's not a lot of details. The alien wouldn't know exactly what's happening past just the most basic structure of what a bird is. And so that's how you should view this picture of an atom. All right, so now let's move to our second picture, our picture in the middle. And so this is the picture that we usually end up using the most in class because it ends up just having the most useful things for us to think about, even though it's not the most accurate. And so if we look at it one more time, we can see that it has the same 2 components as our first atom. It has the orbitals and the nucleus. And so now we can see a little bit more details, and we can see that the atom is actually composed of particles. And so inside the nucleus, you have 2 different types of particles. You have protons and neutrons. And in the orbitals, you have electrons. All right, and so a couple more things about this picture. If we're going back to our teaching an alien what a bird is, this would be kind of like this type of bird. So kind of like a cartoon. So this would show the alien a little bit more detailed in that first picture, right? Now you could be like, a bird is a thing that has eyes and legs and a couple of wings. It would kind of understand the bare bones of what the bird was a little bit more than with that first picture. All right, and so now let's go to our last picture on the right. This is the most accurate. This is the closest out of all three pictures, what they really look like when you actually do get a super powerful microscope and take a picture of an atom. And so now we can see we still have the same two parts. We have the nucleus, the hard, dense part in the middle, and then we have the orbitals here. And so this picture also explains why the orbitals have another name, which is the electron cloud. And so back to our alien bird analogy, this would be like showing the alien just a photograph of a bird. It'd be the most accurate by far, but for something that had never seen a bird before, might be a little bit hard to understand all the details. All right, so when you're in chemistry class, you can kind of keep all three of these pictures in your head to help you visualize atoms. Remember that it is really hard to think about these things because we're never going to see them, and they're so much smaller than us. It's just physically hard for our brain to imagine things this small. So cut yourself some slack and just keep these three pictures in mind, and even though you'll probably be using the middle one the most in class. All right, have a good day and enjoy your chemistry studying.
Proton, positively charged of the particles. It is found within the atomic nucleus.
Neutron, uncharged particles found within atomic nucleus.